We're going to take a look at factoring using the factoring pattern for ax squared plus bx plus c. And what does that mean? Well, it means that instead of having a 1 in front of the quadratic term, we have a number that is not 1. Now, the issue with this is, typically when you have your binomial pair of factors, it's pretty easy to put it together into a form that fits this mold. And quite honestly, the idea of the divided rectangle will also work for these. The catch is, because of this a value, you're going to have doubled, if not quadrupled, the number of possibilities for finding the correct factor form, which means you have to be drawing a lot of rectangles and doing a lot of erasing. Hopefully we can find a way to speed that process up. Let's take a look at our first problem. We have 2n squared minus 7n plus 3. And we are going to look for a greatest common monomial first. Is there a number or letter that goes into all three of those terms? No. The next thing we look for is a difference of squares. This is clearly not a difference of squares because we have non-square terms on the end, which also means it cannot be a square binomial. Finally, we are really stuck with a binomial pair of factors. Grouping is typically reserved for when you have more than 3 terms, more than a trinomial. So we know we are going to have a pair of factors. And when we say a pair of factors, that means you're going to have a pair of parentheses. And in this case, we may have to use the guess and check method several times in order to find it. When I say it, I mean the combination that will work. What do you mean by combination, you may ask? Well, here's what I mean. I'm going to move this up. What I mean is this. We need to find a combination of factors. But right now, I don't know what combination works, so I'm going to look at all the possible factors. And then once I come up with possible factors, I am then going to find out what the linear term will be, the middle term, by adding just the 2 products that would give me my linear term. So let's give it a go. What times what is 2n squared? In other words, I'm looking for factors that go into 2n squared. Well, the options are very, very limited. 2 and 1. So we have 2 and 1. N times n is n squared. What factors does 3 have? Well, 3 has a 3 and a 1. And finally, we need to decide on what the middle sign is going to be for each of these factors. If the last term is positive, that means I could have 2 positives, because a positive times a positive is a positive. Or I could have 2 negatives, because a negative times a negative is also a positive. So right now, I know I'll have 2 of the same terms because of this plus sign. That means we need to look at this sign here, which is a negative, which means I'm going to have 2 negative signs. It's the only way that I can multiply 2 things together and get a positive, yet add those 2 things together and get a negative. And at this point, I know unequivocally that n times n, 2n times n is 2n squared. Negative 3 times negative 1 is 3, positive 3, but I don't know about this piece right here. To figure out this piece, I'm going to have 3 times n. Well, negative 3 times n. Negative 3 times n is negative 3n. 2n times negative 1n is negative 2n, for a total sum of negative 5n. Did that work? No. So I need to try again. Now, in this case, if I change the positions of the 3 and the 1, I will get a different linear term, because whatever is on this in this binomial will be multiplied by the 2n. So let's move that around. I'm going to keep my plain old n here, -1. And let's see if my linear term works. 2n times negative 3 is negative 6n. Negative 1 times n is negative n, for a grand total of negative 7n. That does work. So therefore, this is the combination of factors that will produce my expanded form expression. For my next problem, we have made things a little bit more difficult. Sorry. But not too much more difficult. Here's what I mean. If we look at our trinomial, we again have an a value, and this a value is 12. Thankfully for us, our c value, also known as the y-intercept, is just plain old 1. Well, that makes life much easier because what factors does 1 have? Well, right now you can tell me that 1 has factors of 1 and 1. But I'm getting ahead of myself. Why? Because we need to check for greatest common monomial. Obviously we don't, because this is a 1. We can't have a square binomial or a difference of squares because 12 is not a square number. So I know we have to do the binomial pair of factors again. And we will again have my possible factors, possible sums table. And so let's go ahead and figure out what we can have here. Well, we already know 1 times 1 is 1. Well, what times what is 12? Well, we know that 12 times 1 is 12. K times k is k squared. And again, we have a positive and a negative, so that means we have 2 negative signs. And let's see what we get. 12k times negative 1 is negative 12k. Negative 1 times 1k is negative 1k, for a total of negative 13k. Nope. Let's try another pair. How about 6k and 2k? Because 6 times 2 is 12. Ooh, negative 1 times negative 1 is positive 1, so let's give that a shot. Checking the linear term. 6k times negative 1 is negative 6k. Negative 1 times 2k is negative 2k, for a grand total of negative 8k. Does that work? Oh, it sure does. So there's the combination that I am looking for.